Hello friends! Have you ever looked at a curve and wondered, not just where it is, but how fast it's changing at every single point? That question is at the heart of calculus, and it's answered by something called the derivative. In this video, we'll break down the difference between f of x, the original function, and f prime of x, its derivative, clearly, step by step. Whether you're new to calculus, or just want a rock-solid intuition, you're in the right place. By the end, you'll see exactly how a function and its derivative work together to describe shape and change. Let's go! Alright, so f of x. This is the original function. It takes an input x and gives you back a single output value. Think of it like this. Imagine you are standing on a hillside, and the height of the hill at any horizontal position x is described by our function. For this video, we will use f of x equals x squared as our running example. That is our hill. Now, if someone asks, what is the height at x equals 2? You just plug it in. F of 2 equals 2 squared, which equals 4. That is it. F of x always answers one question. What is the value of the function at this specific input? It tells you where you are on the curve. Next, let's meet f prime of x, which asks a completely different question. Now here is the interesting part. F prime of x is the derivative of f of x. It does not tell you the value of the function. It tells you the slope of the function at that point. In other words, how fast is f of x changing right there? Back to our hill analogy. F of x told you your height. F prime of x tells you how steep the hill is at that exact spot, whether you are climbing steeply, barely rising, or heading downhill. Using our example, f of x equals x squared. The derivative works out to f prime of x equals 2 times x. At x equals 2, that gives f prime of 2 equals 2 times 2, which equals 4. So the slope of the curve at that point is 4. Same input x, but a completely different answer. Coming up, we put both side by side so you can see exactly how they differ. Now let's put them side by side. Same input, two completely different questions. On the left, f of x equals x squared. Plug in x equals 2, and you get f of 2 equals 2 squared, which equals 4. That is your height on the curve. That is where you are. On the right, f prime of x equals 2 times x. Plug in the same x equals 2, and you get f prime of 2 equals 2 times 2, which also equals 4. But this 4 means something entirely different. It is the slope. It is how steeply the curve is rising at that exact point. Same input x equals 2, two different outputs, answering two different questions. One is a position, the other is a rate of change. Next, we pull it all together with real-world meaning. Alright, let's bring this home. F of x and f prime of x are partners, not competitors. F of x tells you where you are. It gives you the actual value of a quantity at a given input. F prime of x tells you how fast that quantity is changing at exactly that same moment. In physics, f of x might describe a position, and f prime of x becomes the velocity. In economics, f of x could be a cost function, and f prime of x becomes the marginal cost, which tells you how costs shift as production changes. Using our concrete example one last time, f of x equals x squared describes the curve, and f prime of x equals 2 times x describes its steepness everywhere along it. Master this distinction, and you have the foundation of differential calculus. Thanks for watching, and we will see you in the next one.